All right, our last example. A golf ball is dropped from top of a building 100 meters above a paved road. In each bounce, the ball reaches a vertical height that is 3/4 the previous height. Determine the vertical height to the nearest meter of the ball after the 7th bounce. So some important wording here, after the 7th bounce. So if we were to visualize this, here is our building that is 100 meters tall. Here's our roadway down here. This is 100 meters. We're dropping the golf ball. Here is our first bounce. Bounce 1. It's going to bounce up to 3/4 of the previous height. And then it's going to drop again. Here's our second bounce. Again, bounce 3. Bounce 4. Bounce 5. Bounce 6. And bounce 7. And we want to find the height of the ball after the 7th bounce. So after the 7th bounce, this is what my question mark is. This is what I'm looking for, this height. So when we look at this, we think the 7th bounce should be term 7 in the sequence. But let's consider these heights. So if T of 1 is our initial drop height, which is 100 meters, our common ratio to this would be 3/4 or 0.75, whichever one you want to use. We have to consider this height. Well, if this is our first height, here's our second, third, fourth, fifth, sixth. This is our 7th height here, and if we want it to come back up, we're actually looking for the 8th height, so the 8th term of the sequence. So again, here's another tricky question. Even though it's asking for the 7th bounce, it's actually relating to term number 8 in the sequence. So thinking about our formula for just the 8th bounce, I'm looking for T of 8. My first term is 100. I'm going to multiply this by my common ratio, 0.75 to the 8 minus 1. And to the nearest meter, my 8th term, which is technically my 7th bounce, works out to 13 meters. Okay. All right, question B. It says find the total vertical distance to the nearest 1/10 of a meter traveled by the ball when it contacts the floor for the 7th time. So again, wording here for the 7th time. So that means we are stopping now at that 7th bounce. So in this case, we are finding the 7th. We're looking for the 7th term here, not the 8th term. But here it's asking for total vertical distance. So what does it mean by total vertical distance? It means we need to know this distance, right? We're adding up all of these distances. So technically, we are finding the sum of the first 7 terms. So thinking about our sum formula, we take our first term times our common ratio to the power of n minus 1, all divided by r minus 1. My first term is 100, so we're finding s of 7. My first term is 100 times my common ratio, which is 0.75, to the power of 7 minus 1, all divided by 0.75 minus 1. So when we calculate that, we get a sum of 346.6 meters approximately. All right, so let's think about this answer now. So this sum would represent all of the distances that the ball has dropped. And when it asks for total vertical distance, are we just including the drop zones? Or should we not be including also the heights in which the ball is rising? Okay, so we've only calculated all these drops. So in order to include all of the heights, What do I need to do to this value? Well, I'm going to double it. I'm going to multiply this now by 2 to include all the heights the ball rises. So now we're at 693 meters, 93.2 meters. All right, well, when we multiply this by 2, we're including all of these rises, but this number is also going to include the ball rising the initial 100 meters. And it didn't. The ball didn't rise the 100 meters. We just initially dropped it from the 100 meter mark. So we do not want to include this initial 100 meter rise. So now from that answer, we're going to subtract 100 meters. To get our final answer. So our final answer should be 593.2 meters. Would be our total vertical distance.